Okay, so yes, we were discussing discovery of electron, whereas this is a discharge tube, not discharge tube, but this is a complete picture. So here we've discharged tube, okay, and this is attached with the high voltage we provide, that would be 1000, okay, and inside we give a low pressure, which is 10 is power minus 3, very low pressure. Then these are the cathode rays, cathode which are the negative charge, anode which are the positive charge. So cathode electrons move from here to there, from like cathode side to anode. These rays are going which are invisible. So when these rays are going, these rays are going from cathode to anode, like from negative to positive. That's why we just call this rays as a cathode rays. So that's why we just say cathode rays name is given like this because of the negative charge, because positive always attract negative, so that's why this anode will go and attract that with very high power. Okay, so electron will go, and here you find some holes in this anode, which is not perforated anode. Then this way will be not perforated anode and would be attracted, but they provide a light green glow is written, but fluorescence would be produced. Fluorescence simply means light or any glow, so then fluorescence would be produces. Okay, I'm sure you're getting. Then we have also attached vacuum pump, which will have them pumping and taking that back. So yes, we were done with the very few important points, which is cathode are negative because they run toward positive, negative run towards positive, they have negative charge, they travel in a straight line because of the opaque medium they have. Opaque medium simply means having no medium, so there will be no reflection, so we can say that the cathode moves in a straight line. That's why we just say there's no diffraction, whereas these are very small particles. Whereas just this point we are discussing, they got deflect in magnetic field, in magnetic field, and produce fluorescence. That's why they produce fluorescence. Okay, and then we just saw that if it will deflect in the electric field, there will be no change and they will form negative. That's so common to discuss in the last videos as well. So I'm sure now we are going to do something big. Just kidding, that big here is, now we are going to change. So what we are going to change, we are going to change the gas they have in this discharge tube, or we are going to change the material or the electrode material, which we have electrode material. We provide the performance and we just play simple, so we just say change in gas or change in material we are going to do. So what will happen, this means we just notice, this means there was still no change, no change when we even change gas or change material. So we say cathode rays don't depend upon what, they don't depend upon the material or any change. This means they don't depend on material, no, not even on the gas, or okay, so I'm sure you've gotten. Then you will find a new term in this topic in chapter, which is E by M. So E here is simply the charge or chain or the energy, but it's just write a charge. Whereas this is the mass, which is M. M. So we just write in the short form E upon M. So what exactly is this? This means E upon M is there is no change of mass, no change of charge, no change of medium. So E upon M, and they have a particular value, which is 7.5, 1.75, sorry, 1.75, which will be multiplied by 10 power 11, and then you find the unit will be C upon kg, because charge is having coulomb, whereas gram is the unit of mass, so C upon kg, and the value would be 1.